us a little bit about the university where you're doing your research.
So I do my research in the University of Poitiers.
Mm-hmm.
So I began work in this university 2 years ago.
Mm-hmm.
We have a lot of research in this university. So me, I am working on eyes research, but in my team we work also in cerebral research, autism, Parkinson, many research.
Tell us about your poster that you presented here.
Okay. So here I am present my research. So I am working on the development of cell model or AMD, so age-related macular degeneration. And I do comparison between ARP19, so an immortalized cell line, and RPE derived from iPS cells. So I take somatic cells from aged people, blood cells, and I reprogram these cells into iPS cells, and after I differentiate these cells into RPE cells, and I induce oxidative stress in these cells, and I compare with ARP19 cells to highlight maybe pathological mechanism leading to AMD.
How do you induce oxidative stress in your particular experiment?
I induce oxidative stress by iron. So I add iron into the media, and by this I induce intracellular accumulation of iron as it occurs in the disease.
What were the results of your study?
So actually we observed a really big difference between ARP19 and RPE derived from iPS cells. So RPE derived from iPS cells seems to be more sensitive to oxidative stress. And so there are more production of oxidative stress during iron treatment. There are more cell deaths, and there are a cell death pattern different compared to ARP19. So it will be better to use RP derived from iPS cells to test therapeutic molecule after.
So if you look at the clinical implications of your research, what are the most important takeaway points from a clinical perspective?
There are two goals for the research. First is to test therapeutic molecules. Maybe we can, with this research, highlight pathological mechanism and test molecules to have new treatment. And second is to maybe one day transplant these RP derived from iPS cells into eyes and maybe not stop the disease, but slow down the degeneration.
Tell us about other research you're conducting in your laboratory.
So I am working on the team of Afsane Gaillard. So she works in cellular therapy in cortical lesion and Parkinson disease. And we have another team directed by Mohamed Jaber working on autism. And we have another team directed by Marcelo Solinas working on addiction, cocaine, etc.
So do you think that addiction and autism and macular degeneration are somehow linked to each other?
They work each other because we use the same techniques, and it's all of this disease is linked to the brain. So maybe there are mechanism link.
I think that's a very fascinating and interesting way to bring things together, to look beyond just the eye and also look at other external influences and similarities in other areas of the brain, because ultimately the eye is an extension of the brain and a very specialized extension, but a lot of the mechanisms that apply to the brain probably apply to the eye in some measure. So where do you see your research a year from now and 5 years from now?
I hope for next that I will do RPE derived from iPS from people affected by AMD, and I want to compare iPS control versus AMD, and maybe highlight pathological mechanism, and after to elaborate new treatment, new therapy. So I hope, and in 5 years, maybe we have great advance in treatment, and maybe we will begin the transplantation of these cells. I don't know, but it would be great.
I think it's a wonderful vision. Thank you for sharing that with us, and thank you for conducting such great research. And we'll continue to watch and to follow and to read about your new results.
Thank you.
Thank you.